Here we go again. Let's see, modeling the Singapore Flyer. A couple of facts that we need to know about the Singapore Flyer is the fact that it is a big Ferris wheel down in Singapore. It was once the tallest one in the world. But besides that, has a diameter of 150 meters, and its total height, right at the top, is 165 meters from the ground. It also moves at 26 centimeters per second, which means that it's moving slow enough that passengers can just get on and get off all the time without it stopping. So looking down right here, we're going to be using this graph that we have here to go ahead and model some of the measurements that we have. So from the center to the edge, that's 75 meters. The only reason why I know that because the total diameter of this thing is 150 meters. Divide that by 2. Now, a couple of things that we need to know is that from the bottom all the way to this part where we get onto the observation wheel, that is 15 meters. This will become prevalent later on. And would stand at a total height of 165 meters. We don't need to really model any of that yet. So the first question we have up here, it says, how many minutes does it take the one capsule to go ahead and make one revolution around the wheel? And what that has to do with is a couple of things. We're going to have this sheet inside of our class. I'm going to give this to you, so you'll get that later. So let's see. How many minutes does it take the capsule to go around? So a couple of things we need to know. Number one, we need to know the circumference of the wheel. Circumference is given by this formula pi d or 2 pi r. But since we have the diameter, let's not do any more work for that. So 150 times pi, which gives me 471.24 meters. Let me just make sure my calculations are correct. And yes, it is. So we're going to have to go ahead and convert this from meters to centimeters. So all we need to do is multiply by 100. So it's 47,124 centimeters. And just taking a look at this right here, since we have 26 centimeters per second, all we need to do is divide 47,124 centimeters divided by 26 centimeters per second. So 47124 divided by 26. That gives me 1812 seconds. But we need to go ahead and put this in terms of minutes because they're asking for the nearest minute. So we divide that by 60 seconds per minute. So divided by 60, that gives us 30.2, which is basically 30 minutes, since that's the nearest minute. Now, before completing the table, explain how the angle values provided in the table are correct. So we have this particular number. We have 12 degrees after 1 minute. How do we know that that's 12 degrees per 1 minute? Just take a look back here. We got to go by some facts that we know. 360 degrees in one circle. We divide that by 30. Cancel. That equals to 12 degrees per minute. So every every minute there is approximately 12 degrees. So let's go ahead and fill in that part of the chart. I'll give this to you guys. So this is 24, 48, 96, 144, 192, 240, 288, and then finally 336. So we have all that nice fun stuff right there. On the next one is it says first inscribed angle that models the situation after 1 minute is shown. So I'll show you that right now. Use additional diagrams and inscribed right triangles to determine more values of the given height. And we're going to have to do this for adjacent side of the triangle. So we're going to be using a little bit of trigonometry. That lovely word you guys remember. So we have this right triangle inscribed within this triangle. We have this leg. And we have this angle. So this is 12 degrees right there. That's after 1 minute. This is the opposite side of the triangle. This is the adjacent side of the triangle. Opposite because when I make it into a little eyeball, I don't know about you guys, but it's always opposite of that angle, and that angle is always looking at the opposite side. So we have so, ka, and toa. These are trigonometric functions. We have our hypotenuse, so we don't have to worry about tangent. We're not looking for the opposite side, so we're not going to use the so we're going to use the cosine. So cosine of theta, which is the angle, is equal to the adjacent side divided by the hypotenuse. And we're given the hypotenuse, which is 75. And we just need to solve for a, so we're going to multiply 75 by we're going to multiply both sides by 75. So that's a is equal to 75 times the cosine of theta. Now, I'm going to bring that down here. I'm going to write that right here. So it says we're looking for a. A is equal to cosine theta. And whoops, made a mistake. So it's 75 cosine theta. Now we're just going to go ahead and plug that in right here. So 75 times the cosine of 12 degrees. So let's see. So 75 cosine 12 degrees. And that gives me 63.28. So about 63. Oh, wait a minute. That's wrong. Sorry. Forgot to check the mode. Mode, radian, degree. Always make sure you put the calculator into degree mode. So we're going to do it again. 73.36. So about 73. And so we look at this. So we're still trying to get the total capsule height. A couple of things that we know now. We know that this is 73 meters. Now, another thing that we know, since this is 75 meters total, and we got an extra 15 meters, the total height from the center of the observation wheel is 90 meters. So that means from here to here, it's also 90 meters. Or from everywhere. Alright, so to do this, I'm not going to worry about this 90 or right across the degrees. So since this is 73 from this part of the leg to this one, that means if I want to go ahead and find out the capsule height at this time, all we need to go ahead and worry about is the fact that, well, we just need to go ahead and subtract this leg from this, and this will give us our total amount of feet. So we have 90 meters minus 73, and that'll give us what's left right here, which is left of that height. Because if you look at this, this will go right back over there. So that's 90. Alright, so that's about it. So let's see. I'm going to write that down. This would be 90 minus 73. And so 90 out of minus 73 is 17. So we have 17 meters. So what we're going to be doing in class is that you're going to have this chart, and you're going to go ahead and fill in the rest. All of it. Okay? Thank you very much. I'll talk to you later. And remember to take the video quiz. See ya.